Let's start. Welcome everyone. Look at you, I'm so proud of you. It's like 5:30 your time and you came here. Amazing. Last session, it is what it is, right? And consider this as a private tutoring lesson to you. It's actually, I think it will be amazing. I will share experience, what we do in my team, in our team in ALE. It's actually we formed a really a group of clever researchers. We explore how we can actually employ agents for tackling the most critical cybersecurity problems. Exploit intelligence is one of them. And before I jump in, maybe a brief bio, so you know that you can trust me. So I did this for kind of 15 years, InfoSec. The AI focus mostly in the last 5, even before pre-LLM era. So did kind of defenses and Microsoft backend, so defended Azure. Right now, in ALE. Talked Black Hat, DEF CON, So agenda, I'll split the discussion in 3, let's say, kind of ALEs. AI impact on the holistically on cybersecurity. Then we'll see how actually vulnerability triage happens, and lately dive deep into the specifically exploit intel with agents. And before we talk about the more kind of specific narrow niche, let's zoom out. And let's think what we are observing right now. And actually, our take, what we see is that we have a problem, right? In cybersecurity right now, there is a significant asymmetry. And what we see is that threat actors are having a pretty good time. The AI automation kicked in, and they started pretty rapidly onboarding on it. We see huge amount of evidence that actually state-sponsored threat actors, ransomware groups, commercially viable groups, they're all employing LLMs to automate their daily day-to-day operations. And while something like Anthropic and OpenAI can and try to combat them, limit their impact, limit their ability to access their models, something like DeepSeek is fully available. It's free, you download it, you spin it up, fine-tune it on your data. I'm sure it's running 24/7 somewhere deep in North Korea for sure. And another piece of evidence is Google's DeepMind report. And these guys know what they talk about. They have a Mandiant and VirusTetal under their belt, right? So they as well see a different set of cost reduction, and that's actually important point, across different threat actor activities. So they see a significant decrease or increase in a LLM usage for something like DOS or phishings or malware creations. The less of that in other domains, because again, AI right now is amazing in code, it's amazing in language, it's less so amazing in, for example, infra automation. And that's what we kind of see across the board. But it's overwhelming. Offensive security has a significant and rapid benefits from an AI adoption. And the worst of that is number of CVs grow, right? And it will actually keep growing more. Why? I'm actually super confident on that. There's as well significant evidence that this is true. For instance, take a look on this stat. It's actually not created by me, sources down there at the bottom. But what we see is that it's a pie chart representing NPM packages, and only 4% of them have had any vulnerabilities disclosed in past. 95% of them do not have any vulns at all reported. Does it mean they don't have any vulns? I don't think so. It's the truth is that some security experts spend his time looking on those 4%, which is probably the most common ones, and huge amount of vulnerabilities still live there. And the question is, what if vulnerability discovery will not be limited by human attention anymore? So it's this 90%, 95% actually become tractable. And again, it's not an empty words. That's what we see as well. In our group, we have a research team focused on vulnerability discovery by means of AI native approaches. And just in last month, when we started focusing on this, 100 plus vulnerabilities. We have 10 plus CVEs, and it's not some low level projects with the low quality code. It's high targets only. So OpenSSL, we have 3 CVEs there in last month. Signal, Linux kernel. This is, for example, communication with Linux, actual Torvalds, about the disclosed bug that we have, and they are fixed it. So yeah, the whole premise of like offensive use of LLMs, it's just kind of early days, adoption grows. And the one kind of worst thing is that when you couple the code and language automation together, this leads to an interesting kind of afterthought or like effect that comes out. It's actually supply chain risks. Because now you can mimic being an actual developer, and you can actually contribute more code with less work, right? And that's what we see last year. XZ, if you remember the case, it was backdoored, right, by an active contributor who was actually multiple months doing kind of work with XZ as a legit employee, but eventually it was again North Korean who like planted the backdoor after 3 months or something. And what they can do as well, it's an LLMs are enabler of this, like because you can do it across many projects at once. Last month we had a worm that hit, I don't know, 100 packages. Then we have the bug and chalk case. If you know that actually like just two packages affected like 50,000 cases or like 50,000 customers. And what we did, especially with this one, again, basically a few weeks ago, we got this chalk library, we like scanned it, and we seen right away the backdoor is there, and it costed us only $2 and 6 minutes. And it's actually hints towards like this whole avalanche of problems that are coming with the offensive misuse. So there is a potential solution, right? We can see it. So back to the asymmetry, threat actors actually having a good time, but yeah, maybe we as a defensive minded people can benefit from AI automation too. Yeah, let's take a look on solution, how it happens right now in, I don't know, what are the vulnerability management platforms, programs doing out there. So let's focus on code first. So this definitely scales to like cloud and infra, but then speaking about AppSec, the atomic unit is code repository. You take basically, it depends on some dependencies, which actually come from out of your decision boundary or like security boundary. It's out there, public, right? The bug might live there, and the bug might actually be exploited out there, right? So what you do right now, it's like you take a person, actually human security analyst, that consumes both sources, the public news or like key events, non-vulnerability databases, and takes a look on your code and correlates this and sees, yeah, actually there is a vulnerability that I have out there exploited, we have to fix it. Before actually fixing, many of them, the vulnerabilities that land on this security analyst table are actually like nonsensical. They do not affect you. So you have this triage process where you discard them, right? If those that are not discarded go to the actual dev or any service owner who like spends his time to actually fix it. And now you repeat this many times, right? You have like thousands and thousands. I actually spoke with CISOs of public companies that have millions of CVs in their networks. It's like just not tractable. So these conventional methods do not scale. It's like the minimal automation out there. Backlog of CVs keep growing. What we explore ourselves as a part of this work, like we see that we can employ AI native methods to see across the code those kind of inconsistencies. So what if we plug a bot here that we actually employ multiple agents together that do this, that is supervised by human? Again, remember the notion of cost reduction, right? It still has to be guided. It just now within like a day you can solve not 10 vulnerabilities but 100 or maybe 1,000 in perfect case. So now this bot can filter out those vulnerabilities with minimalistic involvement of person, and when it's not, it can go and propose remediation fixes. We can employ the integration with the developer actual services that you, as devs do, they actually run the unit tests, they then run validations, so they have to do really minimalistic work just to check that it actually passes. So this paradigm will reduce or at least allow to combat with this backlog of growing CVs, right? But to push it to the limits, you actually can involve the loop idea here, and you can perform a continuous scan here. So, and thinking about that, again, like pushing even further to the limits creates this paradigm shift that we believe that is possible for us to combat this ever-growing threat is of like self-defending software, which of course is kind of holy grail. It's not there yet, but why not? Potentially you can remove any bugs that appear in your code by mistake or by ill intent in this loop of like minimalistic involvement of a human. So yeah, this is a holistic picture of the whole vulnerability triage, where we are, how do we combat these ever-growing threats by sponsors, threat actors. And Exploit Intel is part of it. It's a piece in a huge house of cards. And we explored actually how AI agents can yield here, can help the analysts out there to do their job more efficiently. So how do you actually get something like this when you open your feed, right, on a weekend, and you get like everything is in fire? Like last week F5, then source code was released. What do we do? Definitely right now you don't have any actionable items, but you definitely pay attention more deeply on, for example, F5 instances if they are in your network. Or yeah, basically this story repeats from time to time. Like a month ago it was a SharePoint. So if we decouple Exploit Intel, like how it happens, or like what did it consist of fundamentally. So there are sources that act as guidance missiles for your decision making on actual your vulnerabilities in your environment. So you might know they are there, or you might discover them in process, but eventually you have to kind of figure out, do you have to act on them or not? So this eventually is basically a score. It's nothing too sophisticated. You either see something super relevant to you, like score 10.0, or you can ignore it like 0, in ideal world it's 0, and you completely take it off of the table. There might be other gradations. But what you do usually, like end-to-end matter, it's like a person that does this parsing of exploit sources or news sources and applies it to this non-trivial lineage of all the bugs in your environment. But more mature organizations with whom we spoke with, they actually do a bit of a gradated approach. So they do collection of these sources in their so-called kind of cache, right? Or like some more locally accessible, much more fast storage of those vulnerability exploit informations. And then you have this more of a rapid consumption of these local storage. So for each CV in your environment, you have to do this application. So we tried to plug bots there, right? We gave them enough tools. So we explored in many varieties this thing. For example, with Coral, like you can give them ability to browse web pages like Twitter or basically all those sources. They don't behave well. And why not? Let's step back a bit again. And we didn't discuss where agents are good, where they're bad. And to talk about this, I offer you to look on fundamentals a bit from a different perspective. We all know what is LLM, right? You provide some input, it spits some output. But with all the experience that we have over the years in our team, is that you get some hunches where they work and where not. So in theory, like LLMs are actually like, they take input, right? The capital of France is, and they spit output Paris. So in theory, you can get anything from LLM, and it just depends on in. Like whatever you put in, you can get anything you want. You can get the perfect score for your vulnerability if you prepare this in ideal manner for LLM to make a decision. So that's where agents kind solve it, right? Like speaking about agents, it is an extension of conventional LLM, right? Anthropic offers this paradigm, but we, with all the work that we've done, we offer a simplistic one. Don't think about the all complexity around. It's actually anything LLM can do with an extra context as a tool is basically already an agent. So like memory is just a tool, to be honest. Like query to the rack can be formulated as a tool. So it's like LLM has some lever that it can press, and it uses these levers basically, eventually, to control what information it receives. And this, what information, it's basically a context. And it's super crucial for work with LLMs to improve them, is to understand that context engineering is basically everything. That's the whole, again, that's the most essential thing that you need to master to get out of the LLM what you want. So if we take a look on an agent functionality, right? You have an input. So for example, you ask ChatGPT in research mode to query you for something, for like, I don't know, apartments in your local area. It goes, it does a lot of tool calls, gets information, finds this stuff. But all this stuff is just a context gathering for the last final answer. So basically you can think, again, it's just building the context in a proper way to get this kind of final piece of information, of like chunk of information that all the preceding information like was collected for. So, and there is significant evidence that, again, in like careless approach to context engineering hurts really significantly. So too much information, performance drops. Irrelevant information, performance drops. Again, this is like evidence-based. Lots of academic research shows this. And so this is super crucial to the topic that we just discussed. Again, you plug in the bots into this scraping stage. You give it a curl tool, or you even give it more like targeted tool. For example, you write the whole, I don't know, harness around GitHub, and you give it just search GitHub with this CV. I will provide you all the information from GitHub regarding this. And it doesn't work because, again, as if you attended 2 talks before, Chloe talked about LLMs are not for everything. LLMs are not for scraping. Don't use them for this. They're slow, they're expensive for this. And actually, private feeds here still beat LLMs. So you have a Volncheck, you have a lot of TI-focused companies that do it in deterministic manner, or you can do it yourself in deterministic manner, and it will be much more efficient and actually full than LLMs. But let's consider the second stage, aggregations heuristics. And that's where we plug the bots. They're amazing, actually. So yeah, we trust in technology. We all see, we all use. They actually perform super well on some tasks, and it's like amazing. Like such like intelligence is a utility right now. That's where it shines. So why? Because like it can holistically access the context from different environments. So like you can feed it in application context with the like reachability, exploitability. Then you can feed the context from organization, your app, where it lives, what access it have, like what your devs speak about it in Slack. And then you can give it an exploit intel, and it will calibrate all those previous contexts in a necessary manner. For example, this vulnerability lives out there deep in your network, but is exploited. Damn, this is still like important. Or vulnerability is customer facing, but is not exploited. It's still kind of bad because it might be exploited at some point. So all this can be holistically assessed by LLM models here. And the most amazing thing, LLMs don't care about the format, right? One exploit source might give you this type of data, like Markdown, with links and short description. Another, for example, CISA Kiev gives it in like structured JSON. Usually you build parsers before in earlier days to like treat each of those sources. Integration of new source took like, I don't know, days to build these parsers integrations. Right now it's basically minutes. And again, LLMs consume this data as is without any basically predefinitions here. And the last thing is like simple, no tools. Again, in this case, what we see in many cases, agents actually work, but not everywhere. And in many cases, the simple solutions beat the complex ones. So, for instance, again, back to the Anthropic's definition of building effective agents. They define a so-called workflow paradigm, where you, instead of calling to agents, you call kind of LLM calls with targeted context, and you have a kind of glue them with the deterministic code, like with the old vanilla code, right? And this, in many cases, I don't know, 70, 80% of use cases that we've seen beats all those complex agentic workflows, where like one agent calls another with the sub-agents. Like this simple stuff, where you collect the contexts in a proper manner with the proper context engineering, it's kind of, that's what works, and you don't need anything else. So yeah, that's for example our example how we build high quality context for this final score, including exploit intel. So we collect the data from different sources. Each of them is informed by a set of, again, agents or of workflows, but eventually this leads to another LLM call with a much more informed context that doesn't have anything unnecessary and contains only the core information it needs. So yeah, that's basically it. Recap from me. So there's definitely an asymmetry. I'd say status quo looks poorly if we don't do anything, if we don't integrate LLMs properly in our workflows. I don't know where we will end. The threat actors definitely employ this more and more. And yeah, conventional methods really don't scale here. So we have to, really well, build scaffolding around agents. They don't work out of the box. We have to, with a huge amount of domain expertise to build them in. So yeah, about agents. I don't know, 3 takeaways that I share with you that are not kind of conventionally accepted, but what we see through a huge amount of experience. Context engineering is everything. That beats any agentic complex workflows. Don't use LLMs unless needed. It's like the old story with machine learning, if you know, everyone wanted to use machine learning, well, kind of logistical regression worked, but simple, I know, if-else worked. Here as well, you have to think, do you really warrant for LLM here? And as we see, it's actually in many places, LLMs make sense. We build our approaches in a LLM native way. We solve 80% of the cases, but you still have to have those 20% when the conventional methods beat. And simple is better than complex. Over engineering really doesn't help. So yeah, and basically the paradigm shift of I hope that at some point in future we'll achieve the whole grail of self-defending software. And I don't know, guys, if you have a backlog of vulnerabilities, maybe it will disappear and become zero, right? Yeah. So that's it. If you want to connect, we share our work actively. So yeah, I'll definitely include that in feeds, and I hope we still have time for questions, right? A few of them. Yeah, amazing. So if you have any, I'm happy to answer. Yeah.
I might have missed this. Can you elaborate a little bit? You said that LLMs are really good at you need a parser before an LLM can handle it no problem. What's the difference between that and scraping?
Yeah, we actually don't, point was that you don't need parser, right? It eats any type of format information, but you have to, you can consider this, what is passed in this unparsed way to the model, is a piece of information out there, right? You don't need whole Twitter to consume, right? And the problem is when you kind of feed, okay, this is my feed, take it and read it. And it can see the necessary information out there, but there are better methods to collect, okay, I actually need only these pieces from GitHub. So you cannot do pre-filtering yourself, and then only that information that is relevant is fed into LLM. So if it makes sense, yeah. Yeah? Agent to agent? For sure. You mean even protocol-wise? Yeah, that's Google's creation. That's what you mentioned. Yeah. There's definitely what we see, huge amount of functionality is achieved when you allow LLMs talk to each other, complement each other. For example, criticize. We employed a lot of critics. When you have an LLM that does something and then it passes to critic that basically without the preconditions that were passed to the first model, assumes and solves the flaws of the former one. And in this case, it's definitely a future of machines talking to each other, bots proposing PR fixes and then fixing themselves. We see it. The case about the protocol, I'm not sure. We actually don't use it. We see the more, again, simple solutions work better. Just a pure integration in code rather than more complex divergence to some third-party protocols. And as we've seen, for example, with MCP, which is the similar thing for tools, it actually has its own flaws. It's slow, and it's better sometimes to code the tool natively, like search GitHub. I showed you. You can code it in code and give it as a tool to the API rather than building an MCP with GitHub. So that's what we see with this agent-to-agent protocol. We are not really set to convert to it, so we use our kind of internal methods, and we don't see the need. Like, why? It's so kind of trivial at this moment to connect those models that yeah. Thank you. Do I stop recording?
Yeah, I can close it. If you have any questions, you can meet them outside this room. And then next is the closing. So see you there if you're going.
Is it stopped? I think here.